In the past few years, several academics and practitioners have observed that inflation seems to follow an exogenous statistical process unrelated to measures of slack, such as unemployment or the output gap. And this connects to a broader literature that has documented the flattening or even disappearance of the Phillips curve, especially in the most recent data. Now, whether or not there is a Phillips curve is, of course, important for the conduct of macroeconomic policies, and in particular for monetary policy. So much so that the heads of three major central banks have given speeches on this topic very recently. Turning to academia, in the Nobel Symposium in Economics in Stockholm last year, Harald Julich summarized the state of play, saying that inflation, in essence, dances to its own music. He joined Bob Hall and many other economists in arguing that this disconnect between inflation and measures of slack poses a big challenge to the new Keynesian framework, for which the Phillips curve is a key building block. So the question we ask in this paper is, does this disconnect between inflation and measures of slack really pose a challenge to the new Keynesian framework? And our answer is no, not at all. On the contrary, this disconnect between inflation and slack is precisely what a new Keynesian model with a welfare-optimizing central banker would actually predict. And to make our point, we use the standard canonical new Keynesian model, which we take from Jordi Galli's textbook. Our central banker has a standard loss function that depends on deviations of inflation from target, here denoted by pi t, and on deviations of output from potential, denoted by xt. Lambda measures the relative importance of output stabilization vis-a-vis inflation targeting in the objective function. So let me focus on the solution under discretion. The central banker minimizes period-by-period losses subject to an aggregate Phillips curve or supply equation. This Phillips curve is very intuitive. It says that when the output gap increases, or output increases relative to potential, that puts upward pressure on costs and prices, causing inflation to increase relative to the target. It's also affected by cost push shocks, collected here in the term UT, and it can be shifted around by expectations of future inflation, as represented in the first term on the right-hand side. The solution to this optimization problem is a targeting rule, which is also very intuitive. It says that when inflation is set to rise above the target, the central bank will step in, cooling the economy and causing the output gap to fall. So this targeting rule imparts a negative correlation between inflation and slack, reversing the forces behind the Phillips curve. So here you can see the illustration of the two curves. We have the upward sloping Phillips curve, assuming here that inflation expectations are anchored at the target and there are no cost push shocks, and the downward sloping targeting rule. In equilibrium, of course, we only observe the intersection between these 2 points, the two curves, and hence we face a standard identification problem. This identification problem is made worse by the presence of cost push shocks and changes in inflation expectations that shift the Phillips curve around. So in this particular illustration, the naive econometrician will be more likely to identify the targeting rule than the Phillips curve. Let me highlight one more result from here. In equilibrium, inflation will inherit all the properties of the exogenous shock process UT. For example, if UT follows an AR1 process, then inflation will follow an AR1 process. So it does look that inflation in equilibrium follows exogenous shock. The same intuition goes through in the case in which the monetary authority can commit to a future path of policies. The only difference is that in the targeting rule, we have price targeting instead of inflation targeting, and hence inflation exhibits path dependence. It depends not just on current cost push shocks, but in the whole history of shocks. So bottom line, the new Keynesian framework implies that in equilibrium, inflation rates should follow an exogenous process unrelated to measures of slack, as long as central banks are doing a sensible job. The challenge here is not really for the model, but rather for econometricians. It's an identification challenge. I'd like to stress that our point here is different from most articulations of the Fed's view on why the Phillips curve has flattened. That view has focused on the anchoring of inflation expectations, weakening the reduced form correlation between inflation and slack. Our point, the point we make in the paper is independent of inflation expectations. Even in a setting in which inflation expectations don't play any role, the point we're making is that the structural relation between inflation and slack will be masked by the endogenous conduct of monetary policy. And this is, of course, not to say that the policymakers at the Fed were not aware of our point. Of course, they knew it very well. Yet many people miss the point. And that's surprising because all the formulas I showed you have been around for at least 35 years, going back to Barr and Gordon, so nothing is new here. Yet, interestingly, many papers discussing the flattening of the Phillips curve do not even mention monetary policy. And if they mention it, it's only to the extent that it affects inflation expectations. So let me go to the identification challenge. Ideally, what we would want is a very stable Phillips curve, or at least be able to control for any shifts in the curve, and deviations in the targeting rule that move us along the Phillips curve, so create some variation in the output gap that is independent of cost push shocks or expectations. Now, this is easy to see in the simple standard model. However, in the paper, we stress that the same intuition goes through in bigger, more complex setting. And here I will focus on the big new Keynesian model used by the Bank of England called Compass. This is like our FR bus. Importantly, there's no single structural Phillips curve relation between inflation and slack in this model. There are actually multiple Phillips curves because there are many margins for slack and costs. However, it's still helpful from the perspective of a policymaker to think about an average Phillips curve conditional on demand shocks. Why? Because behind these many margins of slack and cost, there is an underlying aggregate supply relation in the economy and in the model. And this average Phillips curve can get us closer to that underlying structural supply relation in a way that is perhaps more robust to specification than the model itself. So for the purpose of the exercise I'll show you next, we will use Compass and simulate the workings of the economy using all shocks in the economy. We have 18 shocks, a mix of demand and supply shocks. And we will invite an econometrician to run a Phillips curve regression here. And we consider two possibilities. In one, the monetary authority follows a Taylor rule, which is estimated from the data. And in the other case, she minimizes a loss function similar to the one we had before. I call this the discretionary optimal monetary policy, although it's just an approximation to it. So these are the naive Phillips curve that our econometrician will obtain in Compass in this model economy. On the left, you can see the case in which the economy follows a Taylor rule. Here, the econometrician will observe a thick cloud, but will be able to identify an upward sloping Phillips curve. Imprecisely, but at least the slope will have the right sign. As we move towards optimal policy, however, on the right, the econometrician can only see a negative slope. And the intuition is the one I gave you in the simple model. Supply shocks and endogenous monetary policy impart a negative correlation in the data, and this is the result we see in this graph. Let me show you what happens when we condition specifically and separately on supply shocks or demand shocks. And this is illustrated in this set of plots. The first row shows you what happens when there are only supply shocks. In this case it's a markup shock in goods markets. Here, the econometrician cannot identify any positive slope. She observes just a negative relation, and that's it. Again, the intuition is the same as in the simple model. More interestingly is what happens when we move to demand shocks on the second row. In the case in which the monetary authority follows a Taylor rule, which is suboptimal in this case, the econometrician can identify the positive slope, and that's good. As we move, however, to optimal policy, inflation collapses to the target, and the output gap passes to 0. So again, the econometrician is in trouble, and we cannot see the Phillips curve in the data. So turning this into identification strategies, it's clear that a key first step for identification is to be able to control for supply shocks. This is neither simple nor sufficient. It's not simple because many shocks are part supply and part demand. And it's not sufficient because we still need deviations from the targeting rule to move us along the Phillips curve, or at least demand shocks that are not fully offset by endogenous macroeconomic policies. So the solution the literature has resorted to is instrumental variables, initially using lag variables as instruments. This proved problematic because cost-push shocks can exhibit serial correlation, which challenges the validity of the instrument. More promising is what implicitly the literature using monetary policy shocks has been doing. And in fact, this instrumental approach with monetary policy shocks has been recently revived in the work of Barnichon and Mesters, who used estimated effects of monetary policy shocks on output and inflation in order to retrieve the structural correlation in the Phillips curve. In a way, these monetary policy shocks are the ideal IVs. They move the output gap, they are uncorrelated with cost-push shocks, and unlike other demand shocks, by construction, they are not fully undone by monetary policy. So we can be sure that we're deviating from our optimal targeting rule. But there are some limitations, and Valerie Ramey has talked about them, and previously Marc and Eichenbaum. The key problem is that monetary policy shocks have become smaller and less frequent, and if you look at the post-90 sample for the US, they are weak instruments at best. So the solution we suggest in this paper, the most compelling one we can find, is the use of regional data. Why? Well, monetary policy does not fully offset, or does not offset regional demand shocks at the regional level. So effectively, from the perspective of each region, they're facing a suboptimal monetary policy. Each region finds itself with an open output gap and in a different segment of the Phillips curve, which is precisely what we need in order to retrieve the slope of the Phillips curve. And we can use time-fixed effects to absorb any aggregate demand or supply shocks, and also control for time invariant differences across regions. So, this is the here, as we map this into the data, the big mental adjustment you'll have to do in order to follow me is that when I go to the data, instead of using the output gap, I will use the unemployment gap, the difference between unemployment and the natural rate. So my Phillips curve in unemployment space will be negatively sloped, and the targeting rule will be positively sloped. So I think you can cope with that. So just to fix ideas, this is the Phillips curve in unemployment space. The vertical axis shows the quarterly CPI inflation rate in the US from 1957 to 2018, and the horizontal axis shows the unemployment gap. And as you can see, the slope is very flat, and the key point people have been making is that this slope has become smaller over time, particularly in the more recent period. And this is illustrated in this graph here, which shows a coefficient from a 20-year rolling regression of quarterly CPI inflation on the unemployment gap. And as you can see, since the mid-90s, this slope has been shrinking and moving towards zero. So as I move to the regional data, we will use data on 23 metro areas for the US. This is semester data from 1990 to 2018, a period in which the Phillips curve at the aggregate level has been very flat. We use core inflation as a measure of price inflation, and the unemployment rate both come from the BLS. And for inflation expectations, we use the 12-month ahead price inflation from the Michigan survey. Unfortunately, the inflation expectations data are aggregated at the regional level, but that's a limitation we have to live with. And just a couple of comments on the data. Some of the regions here, the metro areas, will have a disproportionate weight. That's the case of New York, Los Angeles, and Chicago, but overall they have the same trends as the remaining metro areas. Our sample covers about 1/3 of the US population, and weighted by the labor force, the aggregated panel data broadly match up to the true aggregate for the US. So it's a good panel. So let me show you the regression results. So all of these columns will show the regressions of metro area inflation on unemployment. They all control for inflation expectations and lagged core CPI inflation. The first column I want to focus on, shows the coefficient, 2 minutes, okay. The coefficient, or the slope coefficient, which is very similar to the one you obtain from the aggregate data for the US. And that's the illustration. Let me go quickly on that. Nothing changes, or little changes, when we add metro area fixed effects. The slope actually doubles when we include year fixed effects, and that's absorbing, again, the aggregate supply and demand shocks, or any changes in the aggregate natural rate of unemployment. And the last one I want you to focus is our preferred specification, where we control for year and metro area fixed effects. And here, as you can see, the slope coefficient is 3 times the one you would obtain from a pooled OLS regression. So, and you can see the illustration with some effort. Here, this shows the Phillips curve for each metro area, and then the resulting aggregates for all the regions. So overall, the results are consistent with the idea that because monetary policy endogenously offsets shocks to demand and it leans against cost-push shocks, it's very hard to identify a Phillips curve using aggregate data. And implicitly, what the econometrician does by using regional data is engineering a deviation from the optimal targeting rule, given that they're all facing suboptimal monetary policy. So just to conclude, of course, everybody knows that the reduced form Phillips curve depends on the mix of supply and demand shocks, and that monetary policy is one of the factors in that mix. However, as I said before, much of the policy and academic discussion in recent years has ignored this point and has estimated the Phillips curve using OLS on aggregate data. That led to a criticism of the new Keynesian framework used by most central banks today, and we think that that criticism is unwarranted. Our paper is a call for a more careful identification, and in particular one that takes into account the endogenous response of monetary policy. Encouragingly, lots of new work are now fighting back on the conclusions from the naive estimation of the Phillips curve. And in the last year alone, we've seen work by Marichon and Messer, Jordis and his co-author, Jordan and Necchio, all, again, providing alternative ways and more robust ways to get at the Phillips curve.